So without further ado, Sean, you can go ahead and let us know how ESBRs are going to make our attendees' lives easier, please.
Thank you for the introduction, Eric. And everybody, thank you for joining us today. We're going to go over a light introduction on Patton's ESBRs and kind of explain the difference between our ESBRs and a typical SBC that we kind of see sometimes inside the carrier environment. So today we're going to go over some pretty basic principles. We're going to start off by looking at kind of the dominance that we're seeing in the marketplace with SIP trunking. We're going to address how the session border router is different than a session border controller. Some of the points why it really does make life easier, the key features, and obviously we'll go over some information on some applications and some contact information for Patton, and obviously we'll follow up the session with a quick Q&A. With that being said, we'll kind of jump into our agenda here. So when we look at the world, we all realize that the price of the telecom equipment is steadily rising, and the knowledge base within inside the organization is decreasing. We're seeing less and less people that are accustomed to dealing with traditional POTS lines and telephony solutions as the next generation of people comes into the workforce. It's much more IP-centric, cloud-centric. We're using multiple devices. We're using collaboration. We're using new technologies. We're looking at the prices of lease lines and PRIs almost becoming impractical to deploy in the office space. And bandwidth has become much more of a commodity situation as we look at the proliferation of fiber, of 4G and next generation wireless technology. And then of course we see, bring your own bandwidth. SIP trunking is much more accessible. And I think highlighting some of the global numbers down here, we can look at, the growth rate between the U.S. and roughly, a handful of years, a 10-year period, we've gone from roughly, a third of our society being on the internet to where right now we basically have a 78% rate of people that are utilizing, web-based collaboration, communication, access to the web from a business perspective. So when we look at our session border devices, we really want to look at it from a very basic level. The session border routers and controllers obviously are SIP-aware devices that sit on the edge of a customer's network. These are our demarc points into our network. They're providing our interoperability with different SIP carriers, different SIP codexes. They're allowing us to do management and control of our users. And obviously, we're providing security and bandwidth control. Bandwidth control is probably one of the key features because this is what it's going to allow us to use our bandwidth to prioritize our voice traffic, which is obviously key in communication. So when we look at session border devices, we're terminating two SIP legs per call. We're making the routing, forwarding decisions based upon that packet. Where does this packet go? What type of QoS am I applying? What type of codec am I applying to this packet? So it's not just IP. And obviously, all of these feature sets are manageable, configurable, and customizable to the individual customer or provider. So this gives us the ability to have almost a split configuration where from our core to our edge device, maybe the provider has a bunch of parameters they're putting onto the customer. But then on our customer side, it gives us the ability to enable VLANs, traffic communication, and shaping, so we're getting the most out of our network connection. Typically, the SBC has always been thought of this large core device that sits within a carrier network. And what we've realized from a perspective is we want an ESBR. And some of the subtle differences between these we're going to kind of walk through. And from a session border router, what we're doing is we're supporting generally from 1 to 200 simultaneous calls. And depending on the call ratio, that could be 10 to 1,000 active extensions. Obviously, this is always, when we say generally, it's a customer-based equipment. And generally, this could be going into a hosted provider. It could be going back into a traditional provider. We're sitting at that edge, providing our security features, our DOS protection, IPsec tunneling and termination, and the big things are the SRTP and TLS, which are kind of our next generation protocols going into our cores. and allows us to interoperate with the telephony cores of our trunking providers' carrier environments. The biggest feature is the QoS and bandwidth management combined with a fully integrated router. So it allows us not only to do bandwidth and QoS, but also routing, VLAN shaping. It allows us to really expose the routing core into our SIP trunks. And obviously, from a pricing perspective, we look at a session border router that is generally going anywhere from a $500 to a $5,000 price. Where when looking at session border controllers, these are much larger devices. You know, we're supporting anywhere from 1,000 to 30,000 simultaneous calls. So we can have anywhere from 10,000 to 100,000 active extensions. It's generally that carrier core equipment. It has advanced fraud algorithms, and this device is integrating with multiple edge devices from various providers. And basically, it provides some area response and some SIP messages. It also does the QoS and bandwidth management, but obviously comes with a much greater price tag. We're looking at that $15,000 to $150,000 price tag, where it's really sitting in that core. And most of the SBC functionality is designed for core communication versus edge-to-core communication. So when we look at it, why would a carrier want to deploy an ESBR versus an SBC at the customer prem? Well, obviously, there's going to be some price considerations. There's going to be time for that ROI. But the most of it is to guarantee that MOS, or that quality down to the customer prem. So that customer is still experiencing that 5 nines quality over a SIP trunk with the bring your own bandwidth type of environment. Obviously, it provides very powerful troubleshooting tools that once your organization understands it for an ESBR, it applies across all of the Patton products. So when we talk about SIP normalization, this is really a big thing where maybe in the customer prem we're running G722, we're going out into a carrier network at a different codec, or a lot of times we're utilizing that G722 in our uplink bandwidth to take advantage of multiple calls on a smaller pipe, and then coming into the prem, we're delivering like a G711. So with the interop, obviously that's where Patton comes in. You know, Patton is working with the SIP trunking providers. We're working with the IP PBX manufacturers such as 3CX to deliver a true quality solution, not only from the IP PBX, but all the way out to the other end of that call. And obviously, it makes it easier if our engineers and your engineers are using one common operating system, one common environment, and obviously we're relying on that accountability for the QoS issues to keep everybody in our marketplace happy and kind of reduce the trend. We've also gone through and created automatic provisioning. So therefore, most of the providers will be enabled through our redirection service at no cost to deploy devices to the customer prem with no truck roll, without a single touch, which is really an ability to grow this market for all of us. And obviously, it's going to tie in with the element management systems that the various carrier platforms may be using. And then we have very powerful CDR tools as well. So we can get our detail, our billing information, and what we're trying to do for the carrier is present that edge device. Where in the enterprise, it really comes down to the SIP normalization, because we could be fluctuating between carriers, we could be changing PBXs, and a lot of people are doing this today. We're migrating from our traditional legacy-based premise PBXs and moving into IP PBXs like 3CX, and we're setting up multiple locations. We're now bringing in presence. We're now bringing in video. We're now bringing in collaboration. All of these types of services really put much more resources onto how we're going to route that traffic and how we're going to prioritize that traffic. So that's basically what Patton is doing with our partners out there like 3CX. So what we don't want to do is we don't want that PBX on that prem to be viewable to the public. So what we're going to do is isolate that behind a split configuration where it's private on the IP on the customer side and then deliverable to the service provider upstream. Obviously, it helps with DOS protection. the encryption from side to side, whether it be IPsec tunnels, SRTP, or TLS. We're also adding a SIP proxy. Right now, we're doing a back-to-back user agent. At the end of this quarter, we'll be introducing our SIP proxy into the products as well. It's just a downloadable feature. There is no associated cost with Patton for software downloads or support for that matter. You know, you've invested in the device once when we've rolled out our products. Obviously, the same goes with our IPv6. It's going to improve our voice network, and we don't have to worry about the scheming that's going to be taking place in our service providers. The big thing we see at the enterprise is the QoS and the transcoding. The reason being is that the enterprises can now fully optimize the bandwidth on the customer prem by utilizing a lower bandwidth codec internally or upstream, and internally still relying on a G711. So when we look at some of the common feature sets that we find in our ESBRs, you know, the greatest thing about Patton's devices is we've taken the rock solid foundation of our SmartNode voice over IP products that are deployed globally by most of the major carriers and incorporated not only that voice over IP and routing set, but have now involved our high-end Trinity routing and SBC feature set to create a truly unique platform. So when we look at our call control, we're really talking about routing and policy decisions. How are we going from the LAN to the WAN? What type of SIP registration management are we doing? Inbound and outbound. You know, quality management, I think, is probably the biggest thing. You know, IP to IP codec, transcoding, and obviously faxing is still a major piece in most businesses, and for a lot of the trunking providers, still a big headache in their network. We always look at the prioritization of the voice, right, for our quality of service. We want to make sure, and Patton has a unique patented system where we do what we call downstream QoS. Downstream QoS enables that all the SIP sessions take priority over the data packet. We never want to have a break in the SIP session because obviously it will disconnect our call. We're realizing data will always keep sending and sending until it receives that acknowledgement. So we're going to prioritize the bandwidth to focus on the telephone calls. And then when that bandwidth comes down, your employee may have access to their YouTube, their social sites, or whatever that are more bandwidth intensive. And of course, survivability is another key feature in the enterprise and carrier market. We have to have alternative routes. We need fallback. And in some cases, we need local breakout in case our network is down for survivability. And obviously, we're focusing on our products, not just a controller, but the complete access routing for our WAN options, our VLANs, VPNs, PPP, protocol translation, VLAN tagging, bridging. These are all very real issues within our enterprise space. So today, from a back-to-back user agent or B2B, we're doing SIP domain separation and VPN. And eventually, we will move that into that SIP proxy. But it allows also all of our local devices to register to the device. And in the case of a network outage, still perform from a LAN perspective back out to our communication network. And interoperability is very big, especially with Patton. You know, we try and go out with the majority of the providers and interop our products, whether that be from, you know, the big three in the United States to the tier 2 carriers to the tier 3 regional carriers, and then of course all of our SIP trunking providers. We have an extensive list of people that we have tested and interop with, not only from a soft switch perspective, but from a network perspective. And we constantly grow that list of partners. So when we look at the ESBR, you know, we're going to look at a couple business cases here. In interop or normalization, this is a really big thing we find in the enterprise space, and it could be where the Microsoft Skype for Business or a Link solution is a hosted play, like an Office 365. The big thing is that Microsoft or Office 365 product is going to be speaking TCP SIP. Well, all the internet telephony service providers and all the carriers speak UDP SIP. So here we have to bridge or harmonize our SIP sessions. And a lot of times, you know, we are actually just doing that translation from one version of SIP to the other. We're not doing any transcoding here. We're letting, unlike SIP language or talk. So that's where we can, with the SIP normalization. And additionally, we can come off a Microsoft platform into one of our ESBRs and enable non-link certified devices, such as cyber data, paging equipment, alarms, and key systems that are most of our school systems and hospitals across the United States. So it helps them bridge the technology and also be aware within a Microsoft environment. Additionally, one of the largest things we see is the QoS and transcoding, where we're doing LAN-to-WAN routing, QoS, and security. And this is one of the largest deployments we have to date with our ESBR families in Swisscom in Switzerland, where our 4580 devices are really there to interoperate with the multiple IPv6 providers on the customer prem to guarantee that G711 provide the SIP register into the SmartNode and then go upstream at a lower bandwidth codec, like a G729. This is probably the most common deployment, but it also allows our provider to have transparency all the way through to the customer edge, which is very key in a hosted or an over-the-top provider model where you may not be utilizing your own trunk lines. So therefore, having visibility down to your endpoint is critical, because you want to know when your customer or when that environment is experiencing any type of troubles. So you can proactively engage the customer and make routing decisions based upon the traffic shaping and the current bandwidth. When we look at our partners, one of our largest partners in the globe is 3CX. Obviously, from a manufacturer's perspective, we support a lot of different people. Microsoft, Avaya, the majority of our partners are deploying like 3CX solutions. A larger enterprise customers, we are bridging the link between their traditional systems and applications such as Microsoft. When we look at our soft switch partners, this is obviously kind of key to where we fit in the marketplace and how we can support interop. Because regardless if the carrier is a large carrier, a small carrier, a hosted carrier, a lot of it all depends on how we are positioned with our soft switch partners. These guys in the core SBCs within these networks are the things that are going to enable the communication links between our customers and various customer cores. We spend a lot of time in the BroadSoft environment here in the United States because BroadSoft is the backbone behind a lot of the Verizons, the AT&Ts, CenturyLinks, and a lot of the larger carriers. And their platform is slowly but surely starting to migrate down into the Tier 2, Tier 3 carrier market. And we also, I'd like to point out, though, one company that isn't represented here is Metaswitch. Metaswitch we don't have a formal interop with, but we have many providers in the United States and globally that are utilizing Metaswitch and Patton together. We're in the process of completing that. But you'll see that our soft switch partners really enable us to globally go into most markets, and it gives us a lot of flexibility from what is being utilized at our customer's core, and we're not asking them to modify or change that. Additionally, from a VoIP provider's perspective, and this is just a handful of the guys that we have globally, we have a lot of the smaller guys in the United States, we have a lot of the global guys, we have a lot of the independent guys. We have a very long list of telco partners that we keep growing on an annual basis. And generally with Patton, the reason why we're selected as this edge device is the solid nature of the device. The device is installed once and it stays up, and they're not touching it. We're that unsexiness in the closet. We're not the application on your desktop. We're not the beautiful Yealink phone. We're not what you see every day as your communication tool. We're that engine that sits in the closet and just has to work because it enables all the other functionalities on our desktop to kind of incorporate this unified communication environment. And when we look at our enterprise session border product line, we've divided into a couple different products. And I think it's pretty easy to look at. And right now, We start with our basic product or our low-end product, which is our SN5200. It's running our SmartWare operating system, supports up to 32 calls. We do have the IP routing in there. It is not supporting the transcoded calls. It comes equipped with the 5 Ethernet ports, and it does have an optional X21 LAN interface. I know this seems a little bit odd to most people in North America. One of our largest carrier customers in South Africa, and their whole network is based on X21. The 5300 is probably our largest deployed unit. It's running our Trinity operating system, which is a combination of our voice over IP SmartWare and our routing core that we call Trinity. And Trinity is what we're migrating all our software to have a common core across all of our products. These devices are supporting up to 256 SIP sessions. They're also supporting the IP router. They're also supporting up to 4 Ethernet ports. They have GDOT interfaces, ATM interfaces, and EFM interfaces for an uplink. Our 5480 series, now these series can support either SmartWare or Trinity. They will run up to 196 sessions. And when we do transcoding, you'll see that basically we cut our sessions about in half, because we're taking half of those sessions to support the transcoded calls, where it's actually doubling the amount of our links. We are also supporting, obviously, the IP routing core. We're supporting our Ethernet ports, and in this case, we're also supporting the transcoding module. Our next generation, or our 5490, is very similar to the 5480. The only difference is this guy is now incorporating various type of WAN accesses. G.SH DSL, fiber, X21, EFM, and our next generation of these product lines will be supporting analog, BRI, T1 right out of the box. We have a lot of these units in last stages of beta right now. We're waiting for the market feedback, and we're really excited about the launch of our next generation of these products as well. And with that, it's a quick introduction to our ESBR line, and hopefully we can generate a little bit of questions here.
All right, if anyone has any questions for Sean, go ahead and type them into the question panel now. If not, I'm sure we'd be happy to answer them after the fact. If you think of anything right after you hang up, just shoot us a quick email. I'll be glad to answer for you. So I'm not seeing any questions come through. Sounds like everyone is an expert on ESBRs and their applications. After your presentation, Sean, thanks so much for sharing that with us. And to all our attendees, thanks so much for tuning in. I know your time is valuable, and we appreciate you joining us here today. Thanks, guys. Oh, Glenn's asking how Sean got so cool. I can answer that. He just came that way. So
Very nice.
All right, guys. Thanks again for tuning in. Take it easy.
Thank you. Thank you again, everybody, for joining.